Welcome to another edition of Long Distance Learning Calculus Style with yours truly, Mrs. Fox. So great. Today we're going to be doing some notes about polar functions. We're going to review a teeny smidge about how to convert between coordinates, and then we're going to start dabbling in how to get ourselves from polar to something that we can work with so that we can do calculus with it. So let me share my screen. We're going to get that PowerPoint pulled up. If you do not have your no. My brain, it's like super scrambled. So sorry. I have no idea what I'm doing. Okay, I want you to go get your graphing calculator. So while I'm doing this, you go fetch your graphing calculator. Okay, go. Why are you still sitting there? Scoochy scooch. Here we go. All right, PowerPoint, pulling it up right this moment. Here we go, peeps. And so for today's lesson, it's technically our day 2 of polar, because I really wanted to make sure that you guys had some time about the polar curves. The next lesson is definitely going to have to do with calculus with the polar curves. So I'm glad that we had our chance to figure that out. So just as a reminder, when we talk about polar coordinates, no, they're not points that are like, Julie, you're so silly. No. These are points in the plane that are just defined a particular different way. Okay, we're always going to call a polar coordinate as r comma theta. Okay, so the r goes first and then theta comes second. R is basically your distance to the origin, basically like how many steps you would take from the origin, and then theta is your directed angle. It operates just like our trig angles do, very just from the positive x-axis and looping around counterclockwise. So in Cartesian coordinates, maybe we could consider this point like 2, 2. Great, love it. Okay, well, what would that look like? Okay, from a Cartesian perspective, it means we would go 2 to the right, and then we would go 2 up. And 2 means it's an x coordinate and a y coordinate, right? So like for sure, let me just get this pin going right here, okay? This is our x guy, yep, in Cartesian, and this is our y guy, and we're super excited, and yay, okay? So now how does that same coordinate look like if we're going to do it with polar, okay? So if we're going to do it with polar, we need to figure out what the r is. Basically, it's just like doing the Pythagorean theorem with your x and your y coordinates. That gives us the square root of 2 squared plus 2 squared, which is square root of 8, which is 2 rad 2. And then we have an angle of pi over 4. How do I know that? I'm going over the same over and up the same amount. So of course that makes a beautiful isosceles triangle. And so what that means for us is that we are going to make this be 2 rad 2 and then an angle of pi over 4. And then what does that look like? Okay, the coordinate, and look how, it's nice. 2 rad 2 for the r and then a pi over 4 for the theta. So that's how it works. Beautiful. Okay, so then let's talk about now transferring between the coordinates, okay? So if I give you a certain polar coordinate, you're of drawing the picture and then thinking about draw a picture, you guys. That's really all there is to it. Okay, so here we go. An angle of pi over 4 would be right here. If I'm taking 4 steps, then that means I'm going over 0 and up 4. So at an angle, this guy right here, this is our angle of pi over 2. I walked 4 steps. It does have a coordinate of 0, 4. Easy cheesy. Okay, what if we have this one? It's negative 3, pi. Okay, so that negative right here does actually mean something, okay? So that negative means we're not going to walk forwards. We're going to walk backwards. Yes, back it up. So we are going to do this. So let's say we had an angle of pi. Okay, so an angle of pi is going to take us to this guy right here, but we're not going to walk forward 3 steps. We're not going to walk this way. Okay, we're actually going to walk backwards 3 steps, and that puts the coordinate over here. So this is actually the coordinate 3, 0 in rectangular coordinates. We go to a 4th example. This says we're doing a 5 pi over 6. So this one is, don't be scared, not on a quadrantal angle. It's not on an axis. Not a problem though, you guys. We're still going to be able to do it. So 5 pi over 6 would be about right there. If we make this a 16, we can channel our 30, 60, 90 triangles. We can think about doing r cosine theta or r sine theta, whatever it happens to be. I'm probably just going to channel 30, 60, 90. Okay, this guy right here is going to be our 8, and then this round right here is our 8 rad 3, and we're moving in a negative direction. So negative 8 rad 3, comma 8. And last but not least, we've got 2 negative angles happening. Woo, crazy. And not a problem, though. We're just going to graph a negative pi over 4 for the angle and then walk negative rad 2 steps. Okay, so negative pi over 4 is actually going to be this way, right? That's a negative pi over 4, but now we have to walk backwards. So we're actually going to walk this way. Okay, that looks super ugly. So let me erase that. But that's basically what we're going to do. So just let me get it. And then there's our angle. And so if that's a rad 2, what would the coordinates be for the x's and the y's? That would be a 1 and a 1. But we're going left 1 and up 1. And so there it is. Look how amazing that all looks. Beautiful, beautiful, beautiful. So now let's reverse it and let's go the other way. Okay, now this is a little bit different instructions, you guys, okay? The different instructions say this. It says find 2 different sets of polar coordinates, okay, to go with the rectangular coordinates. That's because just like what we saw on the previous examples, you can like go either way for your angle. You can go positively, which it would be going counterclockwise. You can go negatively, which would be clockwise, or you can walk forwards or you can walk backwards. So kind of like there's infinitely many answers, and all I'm asking you to come up with is 2. And so I'm going to come up with like 3 or 4 for each one, so that we can have options, okay? So this first one is 1, 0. Now this is in rectangular coordinates, okay? So at 1, 0, what can we talk about? Well, it can have an angle of 0. It can have an angle of 2 pi. We could even have an angle of pi. We're going all the way to here. That was so sloppy. Going all the way to there if we walked backwards 1. So here's a couple of options. So 1, 0, meaning that the radius is 1, right? Because remember, this is r and this is theta right here. Okay, so r and theta. And maybe that's one choice. We could also do a 1, 2 pi. Very nice. Maybe I want to do like a pi and walk backwards. Okay, or negative pi and walk backwards 1. I mean, honestly, guys, there's so many different choices of what you could do. We could even travel all the way back around, like doing a 360, but travel going clockwise, but still walk 1 step. Lots and lots and lots of choices. So maybe for this next set, what I might have you try to do is to pause the video right here. Try to come up with 2 yourself and then see if your 2 match my 2 or any of my 2 for the next 3 examples. That's maybe what I would do. So go ahead and pause the video now. Okay. Hey, I hope we were successful. Let's just kind of zip it around super quick and figure out if you had any of these same answers. Of course, I'm going to start by drawing a picture. So negative 3, 3 makes it have a radius of 3 rad 2. And so I think I'm going to go straight up with the most obvious answer of 3 rad 2, 3 pi over 4. I'll do another one by going negative pi over 4 so that it actually puts the angle down here and then walk negatively, negative rad 3 over 2. Another one I came up with was to do a 7 pi over 4 and then walk negatively. So many different choices. You may even have something different. Let's do that next one. It says a 0, -4 for the Cartesian rectangular coordinates. The straight up version I might do is 4 steps at 3 pi over 2. I might probably on here is going to be a negative pi over 2 is probably the next one, and walk positive 4 steps. I might also do a pi over 2 and then walk negative 4 steps. Again, lots and lots and lots of choices. Another one that we're going to do is to do 1, rad 3. Okay, so if I'm going over 1 to the right and then up rad 3, you should be able to do the Pythagorean theorem and get that your radius is 2. Quite lovely. And then what kind of angle would that be? I'm really hoping that that just feels right, guys, that this being a 1 and this being a rad 3 and then that guy being 2 right there sends you some 60-degree vibe. So we're definitely thinking about a pi over 3 angle. So I could do the straight up version of 2, pi over 3. I could do a 4 pi over 3 and then walk negative 2 steps. I could do a 7 pi over 3, which would be more than 1 time around and walk 2 steps. And I'm sure there's other options out there. So look at all these beautiful, gorgeous coordinates. And it just, you know, there's lots of options. And all I ask for really in the instructions is just for 2 answers. So if you got 2, you are golden. Okay, so now on our last lesson, we actually did some fancier polar graphs, but we didn't really talk about the basic ones. There is a small typo in your notes just because it was so teensy. I need you on example number 2 for part A and part B to make, instead of saying R equals 2, can you make that be R equals 4 and then R equals -4? It's just going to look better on our notes. Okay, so make that change super quick. Yeah, that was me. I accidentally made a mistake. Oopsies. It's okay. We're easily adaptable here. Okay, so if this is the equation, now, unlike the ones that we did in our previous lesson, this doesn't have any thetas in it. It literally just says R equals 4. So you're like, what? How am I supposed to do that? Well, it's just thinking to yourself, I'm always taking 4 steps. Okay, that's nice. What angle do I take it at, Mrs. Fox? Oh, the angles. No joke. We're going to take it 4 steps at all the angles, right? Pretty amazing. And what that creates is a circle that has a radius of 4 and its center is at the origin. Super fancy. Okay. In part B, we have R equals -4. So now I'm going to back it up, and I'm going to walk 4 steps, wait for it, at all the angles again. And so it's actually the exact same picture. No joke, the exact same picture, okay? Because we're just walking -4 steps at all the angles, but when you accumulate those babies all together, it makes the same picture. And then another basic graph, this one's a little bit different because it only says theta equals pi/6. And so when theta equals pi/6, we're going to just take all the steps at this angle. And that means I can walk forwards and I can walk backwards. And so it would look something like this. It would actually just be a line. Okay, so now let's go ahead and do our polar curves with a calculator. So last lesson, we did lots and lots of them by hand. We practiced them. We put them in our notes. They were gorgeous. And so today we're going to gorgeously graph them on our calculator. So what I think we want to do for all the examples for example 3 is let's write down everything first, okay? So I'm going to like rattle through all this stuff like super quick, and I want you to write down all the details, and then I'm going to switch over and we're going to do them with our graphing calculator, okay? So I'm actually going to write them down with you, okay? It's important that we make our calculator be in polar mode, so we're going to talk about that in just a second. So for this guy, we are going to make our theta minimum because it's all about the window, okay? So we're going to make our theta minimum be 0, our theta max be 2 pi, and our theta step be pi/48. Pi/48 and pi/96 are both really good ways to graph polar in. It makes it have lots of famous values in it. Our x's don't need to be that big. And the reason why I'm choosing these particular numbers of a -1 and a +1 for the window for the y, it's going to make the calculator have a window ratio of 3:2. It's just going to make it look really nice. And it's not going to be like stretched in any weird way. Okay, that is the picture that we are going to get, but I know that you see it right now, but we're going to do it ourselves. So I'm going to rattle through this next guy again. So this guy has, let's see, it's going to have a 0 for the minimum for the theta, then 2 pi, again with the pi/48. Really don't have to change that. But I am going to change my x minimum and x maximum to be -4.5 to 4.5 for the x's, excuse me, and the y's are going to be from -3 to 3. And then this last one, we're going to again graph it from 0 to 4 pi. Our step is still going to be pi/48. I'm going to make this guy go from -6 to +6 on the x's, and then -4 to +4 on the y's. Again, just really thinking about the relationship, right? Like these relationships right here, this relationship, and this relationship, that if you put like 6/4, it simplifies to be 3/2. 4.5/3 simplifies to be 3/2. 1.5 to 1 simplifies to be 3/2. So let me get out of here really quick. And we are going to grab up this calculator. Okay, so you can still see what I'm seeing. So let's go ahead and change the mode. Okay, so I'm going to go to the mode button, and I still want it to be in radians, but I want to come down to here, and I want to go over, and I want to change it into polar. Okay, so we're going to do radian and polar, and then now when we go to y equals, it's going to be in polar. Okay, so I'm going to go ahead and graph this curve. So the first one said sine of 6 theta. So I'm going to enter that in, and then I'm going to go to the window button. Okay, so in this window button, I'm going to go 0 to 2 pi for the theta values. I'm going to make this be, that's not what I'm going to make it be, sorry. Ah! Oh my goodness. Did you guys see what just happened there? Oh, seriously, whoopsies. Yeah. Let me go back and fix that. Hold up, guys. Okay, back in the window. Don't push 0 when you don't mean it. That's all I'm saying. Okay, here we go. Our theta step should be pi over 48. So I'm going to put pi. When I get there, I'm going to put pi, clear. Seriously, Mrs. Fox. Pi divided by 48. And then for the x values I wrote down, I'm going to make it go from negative 1.5 to positive 1.5. That didn't work. This touch screen today is not doing the right thing. Notes would have been much shorter if I stopped making mistakes. Sorry, peeps. Okay, so the x maximum would be negative 1.5 to 1.5. The y is going to go from negative 1 to 1. And then when I hit graph, this is going to be kind of amazing. This is going to be kind of amazing, you guys. Okay, now when you graph it, watch it being graphed, because it's nice to also see how it traces it, because that will come into play for tomorrow, thinking about how this baby's going to graph. Okay, so let me go ahead and graph it, and let me watch it. It's just going to be gorgeous. Oh, it is gorgeous. Look at that. We have a 12-petaled graph. It looks amazing. The radius, the petals are length 1, and it's gorgeous. Okay, the only thing we now have to change now to do examples B and C is the equation and adjust the window just a smidgen bit. So here I'm going to delete this, and I am going to, in fact, graph a 1 minus a 2 cosine theta. Now, I don't think I mentioned it before. Remember, the theta button is your xt theta n button. That's your variable button no matter what system you're in. For the window, I already have it being the 0 to 2 pi and the pi over 48. So I'm only going to come down and change the x and the y values. So it's a negative 4.5 to 4.5. And then down here for the y's, we're going to go from negative 3 to 3. Again, we're expecting a beautiful graph. And let's check it out. I'm watching it being graphed. So good. Okay. A beautiful, gorgeous looped limison. Okay, let's go and do one more just for practice here with our graphing calculators. I'm going to put in 4 sine of theta. And I'm expecting this guy to be a circle. We'll go to our window. I'm leaving those top things the same. I'm going to change this to be a negative 6 to a positive 6 on the x's, and then on the y's, negative 4 to 4. I graph it, and I did something wrong. I graph it, and hold up. Let me go back. I'm sure you caught it because I was being silly. Oh, Mrs. Fox, you're so silly. This is going to be from negative, I did the wrong thing right here. Sorry, guys. Negative 6 to 6, and then 1. That was my fault. Whoopsies. Okay, let's graph it now. And gorgeous. It looks like a circle, just like we wanted it to be. Okay, let's go back to the PowerPoint and do a dramatic page flip if you wish. And let's do the last little bit of our lesson. Okay, so when we talk about changing from polar to rectangular, there's a couple of conversion formulas that are like kind of handy to know. One of them, and these are the things you're going to write down in the boxes. One of them is that x is equal to r cosine theta. Y is equal to r sine theta. We know that r squared is equal to x squared plus y squared based on the Pythagorean theorem. And a nice handy one is that the tangent of theta would be the y value over the x value. So nice, so lovely. Let's put these babies into play with our next example, number 4. It says, use these conversion formulas to show that this graph, which, did we just graph that one? We did just graph that one. Let's show that it is actually a circle, okay? And then let's think about its equation and see if it makes sense when we convert it. And you'll be like, oh my gosh, it totally does make sense. Okay, so first thing I would like to say is that we got to start with this. Now, when you look at this, when I go back to my conversion formulas right here, none of these say just like just sine or just cosine. Like this guy with the sine right here, he has like a, whoopsies, he has an R with him, right? And so this guy right here, I mean, if only the equation on the next page had an R next to it, that would be much handier. So here's the deal. Okay, we're missing sort of like an R right here, and then probably this would be much better if this had been an R squared. So we're actually going to multiply both sides by R. Okay. Oh, I'm just kidding. That's so not what we're going to do. We're going to have a different tactic about this. Oh, my bad. My bad. We're going to do it a different way. I'm going to erase these guys right here. Mrs. Fox totally went over this lesson, and then she forgot that this was doing this way. So sorry. Okay, so we're going to do that y is equal to r sine theta. And so if we just wanted to isolate what sine was, we could call it y over r. So now I'm going to replace the sine with a y over r. I'm going to multiply both sides by r to kind of change up the look. I'm going to get r squared equals 4y. And so like I'm on my way, right? I've been able to get rid of one of the variables theta, which is like super exciting, but I still have this r to deal with. But we did write down that r squared is equal to something. It's equal to an x squared plus a y squared. What I'm then going to do is I'm going to change this. It's supposed to be the equation of a circle, so that's what I'm working for. I'm going to move the 4y to the other side. So I get x squared plus y squared minus 4y equals 0. And then I'm actually going to complete the square. In completing the square, I end up taking half of -4 and squaring it. So -2 squared is a +4. I add it to both sides. And then this is what I get. Folks, this is the equation of a circle. Its center is at 0, 2, and its radius is 2. Ladies and gentlemen, that is exactly what we had just graphed, and isn't that amazing? Check out the connections. I'm so proud of us. Okay, and so we're going to write down one more thing, and then we're actually all done. So this right here, guys, is going to lead into tomorrow's lesson. I'm so excited for you. Okay, so this says parametric equations of polar curves. We're about to make a crazy connection starting tomorrow, okay? If we call a polar graph r equals f of theta, okay? So r is a function of theta, and that is going to be the graph of the polar curve. Then we can define it parametrically like this. The x value is r times cosine theta, and which would be the r, just right from here, right? It says the r is f of theta, so we're going to plug in f of theta. And so we're going to put f of theta cosine theta for the x guy. And then we're going to call the y guy r sine of theta. And again, we're going to replace the r with an f of theta. And just like that, boom, we have two equations ready to go on how we're going to sort of like transfer our equations to the next thing. Okay, so here's your homework assignment. I want you to really get a good grasp on this polar stuff, so it's quite lovely. And then tomorrow, hold on to your hats. We are about to, I can't even tell you how excited I am, you guys. So tomorrow, what's going to happen, okay? What's going to happen tomorrow is that we are then going to be doing, let's get myself back here for dramatic effect. Ladies and gentlemen, we are going to be doing calculus with our polar curves. It's actually going to be kind of amazing. And so that's what we're going to do tomorrow. And stay tuned. I'm super excited. Have fun with the homework. Don't forget to write your name like really big on the top and write the page number and all that good stuff so I know what assignment I'm looking at. I hope you're having a wonderful time. And I will see you later. Bye, guys. See ya.